Welcome students. Next concept is Einstein mass energy relation. So this is a very familiar relation. According to Einstein, mass and energy are related with each other from special theory of relativity. According to him, mass and energy are interconvertible nothing but mass can be converted into energy and energy can be converted into mass. In these two processes, huge amount of heat energy is released. So this is called Einstein mass energy relations. So energy and mass are related with each other. Energy can be converted into mass. Mass can be converted into energy. In these two processes, huge amount of heat energy is released, order of c square, where c is called velocity of light in vacuum, that is 3 into 10 power 8 meter per second. So this is called Einstein energy mass equivalence relation. Okay, next concept is mass defect. Before going to explain this definition, I want to take one example. Here, so this is helium nucleus having 4 nucleons. 1, 2, 3, 4 nucleons. Therefore, the mass of these nucleons, these four nucleons mass, so around 3.997 AMU. I want to take roughly. So 3.997 AMU. This is the mass of this helium nucleus, or these 4 nucleons mass. They are bounded to each other. Now I want to separate these 4 nucleons into separately and measure the mass of each nucleon individually and add up to each other. So finally we get the mass of these individual nucleons around 4.002 AMU. So now listen here students. Here this is the mass of the 4 nucleons. They are bonded to each other, or this is the mass of helium nucleus. So this is the mass of these 4 nucleons. They are individual. So we get difference between these two masses. So this shows that there is a mass defect between these two. This difference in mass called as mass defect. So now we can understand the definition. It is the difference between nucleon mass of the nucleus. This is nucleon's mass of the nucleus and the actual mass of the nucleus. This is the actual mass of the nucleus. So this difference called as mass defect, that is small mass difference called as mass defect, that is delta M. So generally, so the nucleon's mass is represented by, so that is Z is number of protons, this is number of protons into mass of each proton plus A minus Z, that is number of neutrons into mass of each neutron. So this refers to that is total mass of all the nucleons. So this is higher value minus, so this is capital M. Here capital M represent mass of the nucleus, helium nucleus. So this is the relation for the mass defect. So mass defect is equals to the difference between nucleon's mass of the nucleus and actual mass of the nucleus. This small difference called as mass defect. Okay, next concept, nuclear binding energy. So nuclear binding nothing but holding energy. So I want to explain this concept through an example. Listen here. So there is 4 nucleons. So these are the 4 individual nucleons. So when these nucleons are bound together for a nucleus, so this is called helium nucleus. Let us consider this is helium nucleus. So these are the 4 individual nucleons. Here, so I'm already told that in mass defect, the mass of these individual nucleons is higher than this helium nucleus. So then what is meant by nuclear binding energy? Here, this mass can be converted into energy. That energy bound all the 4 nucleons. So that is called as nuclear binding energy. Then what is the definition of nuclear binding energy? It is the energy required to binding the nucleons to form stable nucleus. Here, so this is the energy. I want to supply some heat energy. So that required to bound all the 4 nucleons to form a stable nucleus called as nuclear binding energy. Also, so this can be explained like this also. So it is the energy required to break the nucleons into constituent nucleons. So this is the stable nucleus. So I want to break this nucleus. I want to supply some heat energy. So then this nucleus is separate into 4 individual nucleons. So this is also the definition of nuclear binding energy. So it is the energy required to break the stable nucleus into 4 nucleons, or it is the energy required to binding all the 4 nucleons to form stable nucleus. So that is called as binding energy. ಯಾವ ತರನಾದರೂ ಹೇಳ್ಬೋದು, ಇದನ್ನಾದರೂ ಹೇಳ್ಬೋದು, ಇದನ್ನಾದರೂ ಕೂಡ ನೀವು ಹೇಳ್ಬೋದಾಗಿರುತ್ತೆ. So the expression for nuclear binding energy is so delta M into C square, where delta M refers to the mass difference. This mass difference called as mass defect. Next, what is meant by binding energy per nucleon or specific binding energy? So this is the binding energy of individual nucleons called as specific binding energy, or so it is the ratio of binding energy to the mass number called as specific binding energy, that is denoted by EBN. EB nothing but binding energy, EBN nothing but binding energy per nucleon, are called as specific binding energy. So this is for individual nucleons. So this is for whole the nucleus. Okay, next one. Obtain the relation between AMU and electron volt, or show that one atomic mass unit is equals to 931.5 mega electron volt. When 1 AMU is completely converted into energy, when one atomic mass unit is completely converted into energy, the energy released is mc square. So the amount of energy released is equals to mc square. So this is called equation number 1, that refers one atomic mass unit is completely converted into energy. So now mass nothing but so 1 AMU ಅಂತ ಹೇಳಿದ್ದಾರೆ, that is 1 AMU ನ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು 1.66 into 10 power minus 27 kg. Substitution ಮಾಡಿ E is equals to mass nothing but 1.66 into 10 power minus 27 kg into C nothing but velocity of light 3 into 10 power 8 whole square. Therefore E ಇದನ್ನು ನಾವು ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ, so we get 14.919 into 10 power minus 11 joule ಆಗುತ್ತೆ. ಸೊ ಇದನ್ನ ನಾವು ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಜೌಲ್ನ ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಡಿವೈಡೆಡ್ ಬೈ 1.6 into 10 power minus 19 ಮಾಡಬೇಕು. ಸೊ therefore 14.919 into 10 power minus 11 divided by 1.66 ಅಥವಾ 1.6 into 10 power minus 19 ಎಲೆಕ್ಟ್ರಾನ್ ವೋಲ್ಟ್ ಆಗುತ್ತೆ. therefore ಇದನ್ನ ರೀಅರೇಂಜ್ ಮಾಡಿದ್ರೆ ಸೊ ಎಷ್ಟು ಬರುತ್ತೆ 9.315 into 10 power 8 EV ಬರುತ್ತೆ. ಅದನ್ನ ರೀಅರೇಂಜ್ ಮಾಡಿದ್ರೆ AC equals to 931.5 into 10 power 6 electron volt ಆಗುತ್ತೆ. therefore E is equals to 931.5 mega electron volt. This is called equation number 2. From equation 1 and 2 E ಅನ್ನೋದು ಎರಡು ಸೇಮ್ ಇದೆ. therefore ಏನಂತ ಬರೀಬಹುದು, one atomic mass is equals to 931.5 mega electron